We're going to begin our new unit, and this is going to be kind of on, I would say, statistics. So statistics are numerical values used to summarize and compare sets of data. Oftentimes what we do is we look at the measures of central tendency and measures of dispersion. So measures of central tendency are many times we refer to these three ways: the mean, the median, and the mode. The mean is the average. You add them up, divide by how many pieces of data. The median is the middle, and the mode is the most common. So you should have kind of some background knowledge with that. So again, just comparing, what we're going to look at is really comparing some of the different measures of central tendency. So the data sets at the right give the waiting times in minutes of several people at 2 veterinarians. So again, to find the mean, they add up all the pieces of data and then divide. Because there's 9, they divide by 9. So in Office A, they got a mean of 22. The median can be found by finding the middle. So again, determining if I have 9 pieces of data, it's going to be, let's see here, my 5th one. So the mean is, or the median is 20, and then 24 occurs twice, so that is the mode. Whereas if we look at the second office, the mean wait time is less, the median wait time is less, and the mode, which is the most common wait time, is also less. We're going to kind of use this data for a few examples. Now, if we look at the measure of dispersion, it's a statistic that tells us how spread out our data is. So oftentimes, again, a very common measure of dispersion is the range. And the range is basically the greatest minus the least, the max minus the min. So if we look at Office A, the maximum is 32, the minimum is 14, which gives me a range of 18. And if I look at Office B, I have a maximum of 23 and a minimum of 8, which is 15. So the range is also less. And then we also use this very common method called the standard deviation, which is really a more statistical way to look at data, which is, again, describing the deviation of a data value from the mean. So we have a little bit more of a complex equation here. We read this as sigma. So sigma is also the symbol for standard deviation. So basically, if you notice, we'll take whatever our new x value is, okay, and then this is actually the average. So this x with a bar over it, that means average. So also known as the mean. So basically, we're going to find the difference of all of our data points from the mean, square them, add them up, and then we're going to divide by our number of data points. And then at the end, we're going to take the square root of all of it. So if we use that same data set that we've been using for Office A, so again, to find the standard deviation, we're going to use this formula, and it's going to be like taking, all right, 14 was my number, and then my mean was 22. So I would take 14 minus 22 squared plus, my next data piece was 17, plus 17 minus 22 squared, plus 18 minus 22 squared. Okay, and again, you have to do it for all of them. And then my final one would be 32 minus 22, square it. And then we are going to divide by n, which was 9 in this case. And so when I go through and simplify it, again, it's a lot of number crunching. Notice that when my number is less than the mean, 14 minus 22, that equals -8. But when I square it, -8 squared gives me positive 64. So when your number is smaller than your average, you're going to get a negative. But like when we finished, we got 32 minus 22, which is 10 10 squared is 100. So again, you're going to be adding up all these values, and not sure what happened to that, dividing by 9. So when we get that, we get a total of 290 on the top divided by 9, which is approximately 5.7. So the standard deviation of the first data set A in Office A, is about 5.7. Whereas if we look at data set B, again, to find my standard deviation, I've got this formula, 8, and then my median, or my mean, was 16. So this time, again, it's 8 minus 16 squared plus 11 minus 16 squared plus, and then 23 minus 18 or 16 squared. And then this time, instead of having 9, I believe we only had a total of, oh, we did have 9 data pieces as well, 9 data points. So divided by 9. So when I simplify this, I end up getting the square root of 182 over 9, which gives me about a standard deviation of 4.5. So again, following this this equation, I can determine the standard deviation, which determines on average, or if you randomly picked one, how like kind of far away from the mean is it. And then we can also just talk about an outlier. So outliers can affect your data a lot. So again, one outlier, say like if it's way, way bigger than your other number, can affect a lot of your values. It can change your average. It could change the range. So outliers can be on the high end or the low end. So we're going to take a look at this. You are competing in an air hockey tournament. The winning scores for the first 10 games are below. Find the mean, median, mode, and range and standard deviation of the data set. So again, this will be something that is going to be rather common, is to find all the values. So if I add all these up and divide, again, I'm going to use this symbol so we get used to it. Again, 14 plus 15 plus all my values divided by 10. I'm going to get an average of 14. The median, you got to line them up lowest to highest. So again, that's the trick, is you take your lowest values, 11, 12, 13, 13, 14, 15, 15, 15, 17. Let me do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's go through. My mean is, or my median is in between 14 and 15, which means it's going to be 14.5. That was supposed to be black. That's okay. And the most common number we can see is 15. The range, 17 minus 11 is 6. And then my standard deviation, again, plugging in this big formula, my average is 14. Again, not going to write it all out, but to calculate it, you do have to write down every single piece of data, divide it by 10, and this is going to approximate to about 1.7. The winning score in the next game is an outlier, 3. So find the new mean, median, mode, range, and standard deviation. So now if I look at this data set, but from with a new piece of data, we're going to add in a 3, again, a much lower number. My mean, if I add them all up, is going to be 13 this time. My median, again, I got to now find the middle. So I could, again, if I have 11 pieces of data, my middle is going to be my 6th number, which is 14 this time. And my mode is still, the mode hasn't changed. The mode is still 15. My range, 17 minus 3 this time. My range has increased a lot. My average decreased, my median decreased, my range increased. The mode did not change. And then standard deviation, again, I got to add one more piece of info. 3 minus 14 squared. Again, you guys get the hang of it. 13 minus 14 squared. This time dividing by 11 is a much higher number of 3.5. So kind of already did see which measures of central tendency does the outlier affect the most. It definitely affects the average and standard deviation and range. It could affect the mode. It didn't. And it did affect the median, but a little bit. Again, notice that my range increased dramatically and my standard deviation did because of that one outlier.